So lighting load. Okay, so in this component, so it has three components as well. So we have in terms of the area. Okay, so we also have to allocate for small appliances. Then lastly for the laundry. Okay, so for the second component, so we have to look at although it's not in order now. So it can be in any order as long as you include all these components. Okay, so we also have to look at the fixed appliances. Okay, so there's a provision in this code which says that if you exceed this number of fixed appliances, so you can also apply certain demand factors. So actually, we are we having these different components for us to apply certain demand factor. So we know that ano siya, general lighting, so there's specific demand factor for dwelling setting. Okay, so for example, so this is where we solve for the area. So for example, for the dwelling demand factors, so for lighting load, so we use this uh, part here. So demand factor for first 3,000 is 100%, 3,001 to 120,000, 35%. The remainder is 25%. Okay, so mo na siya diri ang indicate sa demand factor, then also for the fixed appliance. So there's also a demand factor that we can apply here. So no? So this is based on table 220.42. Two 20.42, and yep, so that's for the general lighting load. And for the fixed appliance, so actually if you start from here now, so this is the start of the calculation. So we see here, this is for the general lighting section. Okay, then this is not limited to dwelling units, so it could be any spaces. So that's why we also have here show window, okay, or track lighting, so which is not usually present in dwelling units. Okay, it is usually included for designs of mga commercial buildings. Okay, so if you let's for example ani nga design, so you have to consider that these are the also the requirements for show windows. Okay, so loads of not less than 660 volts ampere per linear meter or 200 volt per linear foot. So man siya ang requirement. Okay, so if you notice, asa man siya makita ni mga show window. So for example, sa kanang mga mga apparels. So nana siya diha. So for example, one store lang. So probably nana siya distance nga 3 meters. Okay, or length nga 3 meters. So 3 meters times 660. So that is the requirement for that show window alone. So wala pa tayo labot tong susunod. Okay, then track lighting. So it is possible to use track lighting no, for your illumination system, but again, this is not the usual type of lighting system used in dwelling. Okay, but if you have this one, so you have to base your calculation on this given said volt ampere. Okay, so 150 volt ampere to be included for per 600 millimeter. Okay, so how about for receptacle loads other than dwelling units? So we have to look at 220.14 H and I. Okay, so then we apply this 220.42 and 220.44. So this is the 220.42. So mali siyang demand factor, and for 44, this is for non-dwelling units. So it depends on unsa ni siyang application. Okay. Then, yeah, so 220.14 I and H. So, sa mga nag-isultihan niya. So, 220.14, so it should be here, no? Yep, so this 220.14 and all occupancies, I and H. So these two. Uh, so we have fixed mount multi-outlet assemblies and receptacle outlets. Okay, so for fixed mount multi-outlet assemblies, so usually no, it's not used for household nga mga outlets. So we can see this in mga, let's say, computer shops. Okay, so in which there are lots of loads per feet in a given table. So you have to calculate your outlets now based on this fixed multi-outlet assembly. Okay, so may pasabot na niya. So you based on H1 and H2. So in which in H1 says that for every 1.5 meter, so you should consider not less than 180 volt ampere. Okay, so diba, this is the volt ampere for one strap of receptacle. Okay, so now we are not considering a per strap of receptacle, but instead per distance. Okay, so much yung multi-outlet assembly. So usually it looks like this now. So for example, this part of the table. So could be nga na siya yung mga outlet dire in closer distances. Okay, so just like what we have in our laboratory, no, in for what do you call that, circuits nga laboratory. So doon sa SAL, near sa SAL ng mga laboratories. So we have this, actually sa SAL no, so yun ani sa mga tables, so na ay mga assemblies. Okay, so although this is this indicates nga we have this multi-outlet assembly, then when we calculate the power or the so allocated power for this, so we now calculate based on distance. Okay, so again, so these are the requirements: 1.5 meter, so we have 180, not less than 180 volt ampere. Then so also, so that is just for Kuana. By the way, this is for multi-outlet assembly in which it is possible nga dili sila magamit simultaneously. But if you, for example, in SAL, so since we are using it for our classes, so therefore mapuno gini siya every time we use it. Okay, so therefore the use is simultaneous, and we now base our calculation in this H2. Okay, so in which we have to base on we have to have not less than 180 volts ampere per 300 millimeter. Okay, so around one ruler lang or 1 foot. Okay, so muna siyang distance, so we have to calculate 180 volt ampere for that. Okay, so that's for H. Then receptacle. So this is what I mentioned earlier. No, so if you, it's not a multi-outlet assembly. So for example, receptacle lang. So if you can remove the faceplate of your receptacle, so you should see there that nana siya yoke, so which is made of metal. So naka-screw na siya to the assembly connected to the outlet box. Okay, so let's say we have it here like this. So we have here two gun receptacle. Okay, so we have here two gang receptacle. Okay, so the allocated here, because they are connected into single strap, is 180 volt ampere. Okay, so 180 volt ampere. Then if we have, let's say we still have the setup, but instead of having two gang, so we have only one gang. Okay, so this is the yoke. So this is where we connect our attachment plug. Okay, so see, this is just one gang now, but still we calculate based on 180 volts ampere. Okay, so this is the, as long as you are again looking at per yoke, so we have 180 volt ampere. But there are some connections in which there are two yokes per box, like this. Okay, so let's say we have now four receptacles, outlets. Okay, so we calculate each of these sila, based on 90 volt ampere. So basically, the same lang yapon no, that per yoke, you should have 180 volt ampere. Okay, so mas na siya ang ipasabot dere, not less than 90 volt ampere ang per receptacle. Okay, so if you have 4 or more receptacle. Okay, so this is for this part, and okay, so that we're done here, and so these are the demand factors. And for motors, again, if ever we have a motor load, no, so we have to look at Article 430. So it's where motors are located. So, siya dire. So I already bookmark my Oh, actually, wala. Okay, so just skip this one. Anyway, we have a separate discussion for motor load calculation. Then fixed electric space heating. So aside from cooling, so it would be that in your design, so there could also be heating. So although in the Philippines it's not typical now, but so we have Baguio in which we can also apply this kind of as a system. Okay, so in which there is a space heating. Okay, so it should be calculated based on 100% of the connected load. So therefore, there's no demand factor now. So whatever is the load, so that automatically will be your demand for that specific load. Okay, so it goes here now. So meaning, aside from the fixed appliance, so we need to have here, so heating or cooling. So actually, I combine these two, no, because these actually are what we call the coincidental loads. Okay, so meaning they will never be used simultaneously. So if the weather is hot, so you use this cooling. If the weather is cold, so you use this heating. Okay, so there will be a provision for this one as well that we have to follow later on. So that's the next component, heating or cooling. Then yep, so small appliance and laundry. So ato na siyang i-apply din, no? So this is the small appliance and laundry. And again, so for small appliance, we need at least two 1,500 branch circuit. Okay, so we have here, this is based on the area. So there's a table for this one. No? And this for the area, small appliance. So two 1,500, so not less than these two V8. Okay, then laundry. So we also need one. So 1,500 VA. So although let me just use this 250, 225 to A and B. Okay, so it's where we look for the provision for these loads. Okay, then before I forgot now, so ako na lang i-apply ang area. Okay, so this is where we look up for a table 220.12. Okay, so it depends on what kind of space you are designing with. Okay, then Yep, so appliance load. So this is what we mentioned by, I mean by conditional fixed appliance. So muna siyang appliance load. Okay, so it's actually in 220.53. 220.53. So what are these appliance loads? Okay, so any fixed in place appliance, no, other than so there's a exception. So we have these electric ranges. So we know that electric ranges are also fixed in place, but since there's another provision, no, for electric ranges, so gilahi siya. Also for clothes dryer, so that's also fixed in place. But again, there's another provision for that, as well as space heating. So you see uh, earlier, gonna type provision for that as well. And yeah, so air conditioning, so that's na siya ilain nga calculation. So same with space heating. So those are the fixed appliances now that you have to exclude whenever you calculate for your appliance load. Okay, so this section tells us nga if you have more than four, no, more than four small appliance, so you can apply 75% to the nameplate rating of that for appliances. Okay, so I already mentioned some, no, last time. So mato silang mga so actually you can use also fan here. So trash compactor, dishwasher. So those are examples of fixed appliances. Okay, other than this I mentioned already. Okay, so but there's also a table for that now. Yeah, so here, not this one. Where could it be? Large load. So maybe later na, no? Anyway, in most in most household, dili man sad malapas gyud by around 4, 5 nga na lang number of small appliances. Okay? So here, as long as malapas by 4, so you mo automatically multiply the total VA by 75%. So we have to multiply 75% of total fixed load lang siya. Okay, so next part is this one. So clothes dryer. So I already mentioned this last time. So let's include it here. 3, 4. Okay, so for clothes dryers, you have to look at this section. So we have 220.54. Okay, so also, none siya specific table for its kuano. So we have to look at here 220.54. Okay, so this says no nga if you have if you are to calculate for a provision for our clothes dryer, so either you look at the nameplate rating of the clothes dryer or you use 5,000 watts, so whichever is greater. Okay, so meaning if you have a clothes dryer rated at 4,000 watt, so automatically we have to use 5,000 watt. Okay, so if you have more than 5,000 watts, we have to look at this 220.54. Here, so this one. So it depends now on the number of clothes dryer to have in that the same service. Okay, so if you have more than 4, so you now have a demand factor of 85%, for 5, for 6, 75%, and so on. Okay, but it's very unlikely for a small dwelling unit to have uh, more than four, what do you call it, clothes dryer. Okay, but this is very popular again, as mentioned, for those areas located in mga Nordic na mga region because they don't have sunlight to dry their clothes. Okay, but if we are again to calculate this one, so we use this provision here. Okay, so 220.54. So let me just take note of that. Okay, so for the next part is the countertop cooking equipment. Okay, so we have here kind of very long table for that alone, this section alone. So let me just 220.55. So the fifth component, so then so let's just call it ranges. Okay, so we look at 220.55, and for the demand factors, we look at table 220.55. Okay, so again, we have to look at this table here. Then I'm going to have some examples for this later. Then 5.5. Yeah, so 5.6. So this is so let us not just go over here, this one, because this is again for other than dwelling units. So we just focus for now to dwelling units. Okay, then this is what I mentioned earlier. If you have non-coincident load or what did I say earlier? So dapat non-coincidental load. Yep, so this should be non-coincidental load. So dapat dili sila magdungan. Okay, so you will just use the largest of the two. Okay, so again, so since we have here, for example, heating and cooling, so we have heating and ACU. So let's say that the wattage of your heating is 5,000 watt, then the cooling is 3,000 watt. So therefore, for this component of your calculation for demand, so just use the greater, which is 5,000. Okay. Then yeah, so mo na siya pasabot sa non-coincidental load. Then for the calculation of feeder neutral, although in our case, so here in the Philippines, so we don't have to bother with this one because we are using single phase. So in American connection, so they use 3-wire 2-phase. Okay, in which they have this neutral conductor. Okay, so this part is located for this conductor. Okay, while we calculate this line conductors, so siya. So same lang sa atong case, so in which we just have to use 230. Okay, or in their case, so this is usually 120, so 120, 120. So if they have a load 120, so they connect from line 1 to neutral, or other loads connecting from line 2 to neutral. Okay, so they will try to balance out their loads always so that this neutral will take a very small amount of current. Okay, so that's why there's a demand factor for this one. But in our case, since we are using again single phase now, one phase, so therefore, so whatever is the current here will be the same current sa dire. Okay, so we don't have neutral to cancel out some of our loads. Okay, but anyway, it's good to know now that we have this calculation for feeder neutral if ever we have two phases. So what we're going to do is just we apply 70%. So this one, so there is this what we call the permitted reduction. Okay, so where is A? Yeah, so A for the basic calculation. Okay, so basically it just says nga should be based on the maximum unbalance. Okay, so as I mentioned, when you identify loads in kung ano, in American setting, so in which you have here two phases. So let's say we already have heating, we have anyway, this can be connected anywhere now because again they are non-coincidental, and we have here they call that close dryer. Then we also have here um, range. Okay, so say that these two are rate using 120 volt, then Kinesia is 240. So therefore, this range should be connected from face to face. So there's no problem here. So it will not affect sa imuha nga neutral load. Okay, so this, when you calculate your neutral load, this should be omitted. Okay, so but for the calculation of the line conductors, so appeal siya. Okay, then these two, suppose we only have three, no? So let's say that this is 500 watt. So gamay ka na, 5,000 watt. Then, okay, so 5,000 watt. Then let's say this is 3,000 watt. So at least man lang, no? So when we use them, so there will be cancellation of current here in the neutral. Okay, but when we calculate for neutral conductor, so we have to base on the maximum unbalance. So what would be the maximum unbalance in this case? So surely it would be this 5,000 because if we look at the number of cases for our operations. Okay, so 5,000. So yeah, so we have to look at different cases of our operation. So let's say both of them are operating. So therefore, the maximum unbalance would be 2,000. Okay, how about if only the clothes dryer is operating? So therefore, the maximum unbalance would be 3,000. And if only this AC or heating is operating, so we have a maximum unbalance of 5,000. So therefore, for our neutral conductor calculation, so we have to use this 5,000. So mo na siyang ipasabot diri sa kani siyang code, part of the code. Okay? But again, it will not apply in our case since we don't have neutral. Okay, then if there are possible reductions, so you can apply reduction. So for example, sa clothes dryer, and ranges. So we can apply 70% reduction for the loads, whatever we have calculated now based on the table given here. So for the line, so we multiply that by 70%. So that would be the reduction part of our neutral load. Okay, then there are also some no, with prohibited reductions. Okay, so asa man siya ma-apply. So yeah, so those with especially mga nonlinear loads and this kind of connections. Okay, so why is it that it is not allowed to have a reduction in load for nonlinears? Because if we actually calculate the total load because of nonlinear loads, so we could have increased harmonics, and that harmonics will have instead of having a cancellation here in neutral uh, current, so instead ang mahitabo is mo add up na hinan sila because probably your waveform is shifted, or it could be nga offsetted by 180, so causing your current to, instead of cancel out, it will add up. Okay, so those are, but of course you have to identify if that load is really nonlinear or linear. Okay, so how do you know that that is nonlinear? So we have to look at the appliance. So unsa man na siyang in general, unsa man na siyang kind of load kana siyang appliance. For example, if that is an electric fan, so since that is mostly kuno man siya, conductor man na siya, so therefore resistor and inductor lang or capacitor. So therefore that is a linear load. So if you have there, let's say mga high switching mga LED powered, ng mga components. So those are kinds of nonlinear loads. Okay, then also for your air conditioner, um, most air conditioner ng mga older nga air conditioners are linear. Okay, but mga latest karon nga air conditioner, especially kanang mga what you call inverter type. So they are, as the name suggests now, inverter type. So they are made of semiconductors. So therefore, it will generate nonlinear loads. Okay, so for the next part now of the sections, it's about optional calculation. So we don't have to go through this one because this is basically just the same to this standard calculation. So there are two ways to calculate for our demands. No? So either we use the standard one or the optional calculation. And usually this optional calculation is only used for mga dwelling units with or spaces with repetitive loads. Okay, so let's say we have there a 10-story building, so in which in every story the loading is almost the same, so you can just multiply those and by 10 and use this optional calculation. But in our case, since we only consider one family dwelling, so we use this standard calculation. Okay, so by far, so we have here um, ranges, dryer, then so may nakalimutan ako. General fixed heating. Okay, so depends now. There's this sixth because it is required actually in, although wala pa dire, it's in 430.24. So largest motor. Okay, so if you have a load, motor load other, so let's just call this other motor load. Okay, so I'm not going there now, but this section says nga, if you have a motor load in your household appliances, so you have to consider 25% of that largest motor load. Okay, so if you have ACUs, so those are considered motor loads. Okay, so you have to look at one of them with the largest wattage or power. Okay, so then you multiply it by 25%, then you add up this value to the total ng mga demand. Then based on this demand, so you can now calculate for your current. So you just divide this total demand by 230 since this is our nominal voltage. Then this gives us the current, so which we can use to calculate for the conductor size, the tube size, and also the protection size. Okay, so yeah, so this is the general nga requirements for dwelling unit calculation. Okay, so let's start with so actually no, I have here problems, so which I retrieved from my previous my exams. Okay, so we can use this now to practice our knowledge on application of those sections. So ano silang mga sections that are entailed here. Okay, so suppose we have this, the neutral. So again, it's not very common to us now, but for mga board exam, so although wala na siya na-apply sa to, but it could be also asked in the board exam. So we have to learn this also. Okay, so the neutral demand load required on the service for 4.5 kilowatt clothes dryer 240 volt would be how many amperes? So mana siyang question. So since this is a clothes dryer, so we have to look at this part here. So 220.54. 220.54. So this section here. Okay. So again, if you have clothes dryer now, so either you use the nameplate rating or 5,000 watts, so or volts ampere, so whichever is greater or larger. Okay, so since this one, or is 4.5. So we have to use 5,000 for this one. Okay, so uh, let me use my calculator. Okay, so 5,000 divided by 240. Okay, so I have here 20.83. But so this is usually the case no in board exam also. So every time you do something, every time you calculate something, so there will always be an answer. Okay, so there will always be a correct answer. But I mean a value that is in the options. Okay, but doesn't mean that that is the correct answer. Okay, so I'm getting here 20.83. Okay, so so I know that this is not the correct answer because this should be the current for the line conductors. Okay, but we are looking here for the neutral demand. Okay, so also, di ba, it's already, we already covered this one that, or we, where is it? So there's a requirement here for, reduction. Yeah, so permitted reduction, so which we can apply for ranges or for dryers. Okay, so therefore, so we also have here dryers. So we can apply a 70% demand factor for this kind of loading. Okay, so 50, I mean 20.83 times 70%. So I have here 14.58. So this time, this is now the correct answer. So kani siyang letter, although supposedly A, B, C, D, you know. So probably this is letter C. Okay, so this is your answer, 14.58. Okay, then what if we were, we forgot to recall in the section in which we have to use the larger of the two 5,000 or the nameplate rating. So we just automatically use 4.5. So 4.5 divided by 240. So I have here 18.75. Okay, so again, we still have that choice here or option. Okay, 18.75. Then if you forgot the section na require of that one, you have to use either 5,000 or whichever is greater than nameplate. So you will end up having this answer, 18.75. Then also, since if you, for example, you also remember, no, you have to apply 70% because of the demand factor. So if I multiply this 18.75 by zero point 0.7, so I'm getting here 13.13. So again, so nagyapon siya sa choices, but this is not the answer. So that's how tricky or deceiving sometimes ang mga questions sa board exam. So you have to be careful. Okay, so for this number 22, so find the demand load for, okay, so going back now, so number 22, okay, so this one. So find the demand load for 150 kVA dwelling unit. So this is, we know now that this is dwelling, then this is the, yeah, so the demand load, this is the load capacity, 150 kVA. So saan siya determine. So we have to look at the table in which we can apply demand factor for dwelling. Okay, so this one, demand factor for dwelling units. So again, so we have this First 3,000 is 100%, then 3,000 to 120, 35, then over 120 is 35, then 25. So how about the given? So the given is 150, so therefore, na siya ay sobra. Okay? Okay, so therefore, if we are to solve this one, so let's have here our solution. Okay, so we are given with 150 kVA, but we have to break it down. So first 3,000, 100%. Okay, then 3,000 to 120,000. So pila siya. So that is 120, 117. 117,000. Okay, so times 35%, then the remainder, 120, so that is 30. 1, 2, 3 times 25%. So this is 3,000, then 117 times 35.35. So I have here 490. I mean 4950. Then 25% of 30, so that is 7,500. Okay, so 3,000 plus 4950 plus 7500. Okay, so I have here 51,450 VA. Okay, so this is our answer. Wait. 451,450. Yeah, so this is the answer. So 51450. So again, so you have to be careful. So you see here, so it looks like this is the answer, but nabalide ayang instead of 450, nahin mo siyang 540. Okay, so yeah, so this is our answer, letter D. Yeah, so for this one, so it's about counter mounted cooking unit. So we have 6 and 4 oven. Then the minimum feeder would be 6 counter mounted cooking unit, and so one 6 kilowatt, then one 4 kilowatt. Okay, so we have to look at now the so we refer to ranges. So ranges 220.55 and table. Okay, so here 220.55. So actually, when you use this table now, so you have to look at these notes here. Okay, so first, over 12,000 through 27 kilowatt ranges, all same rating. So we use what do you call that, 5% nga increase, but since ang atong given is dili man siya over 12,000, so we cannot use this one. Okay, so we'll just have an example for this one later. And so our value is 6 and 4. So practically, asa man na siya supposedly mabilong. So we have for 6, dapat mabilong na siya dire. Then for, actually, diri silang duha, no? Sa letter B silang duha, 6 and 4. Okay, so over 8.4 to 27. So still, dili siya diri nga part. But if you read this through, no, so you see that here in note number 4, so branch circuit load, it shall be permissible to calculate the branch circuit load for one range, okay, using this 220.55 Then the branch circuit load for one wall-mounted oven or countertop unit, okay, shall be the nameplate rating of the appliance. Okay, the branch circuit load for uh, the counter-mounted cooking unit, not more than two wall-mounted ovens, all supplied from single branch circuit and located in the same room, shall be calculated adding the nameplate rating of individual appliance. So therefore, we have to consider that these two appliances are, since they are connected in a kitchen, so therefore they are located in the same room. So we can assume that this is a single load. Okay, so we just add 6 and 4. Then, saan siya nabilang? 6 and 4. So therefore, it now exceeds this column B because we have 6,000. Yeah, 6 kilowatt and 4 kilowatt. So again, since they are located in the same room, so as given in the problem, so not just kitchen, so we supply the same feeder for these two loads, so we can consider that they are connected into a single branch circuit. Okay, so that is so we add their nameplate rating according to this note here. So then we consider it as one range. Okay, so one range here. So if it is already one single range, so we can now consider using this table. Okay, then one range with a rating of 10. Okay, so here, so as long as your range does not exceed 12 kilowatt, so from 834 to 12 kilowatt, so you will use this rating. So therefore we use, and there is just one range, so we use 8 kilowatt. Okay, so see there is demand factor since uh, the total supposedly is 10, but we are just considering that the demand for that feeder is 8 kilowatt. Okay, so this is the answer, 8. Sabtan ba ni siya apart?
Yes, sir.
Okay, so how about this one? So we have here, so actually, in these problems here, so we are targeting almost each of the components now in our calculations. I mean, in our dwelling unit calculations. Okay, so here, so this it's about fixed appliances. Okay, so we have, so find the demand load for 6 fixed appliances. So there are 6 and the total is 14,600 VA. So we have to look at the requirement demand factor no, for fixed appliances. So we already have it here, fixed appliances. So we have to look at 220.53, so in which it says if there are 4 or more fixed appliances, so we can apply 75% demand factor. Okay, so we apply it here. So 14,600 times 75%. So I have here 10,950. Okay, so therefore the answer is letter A. Okay, so yun na lang. So we just every time we have a problem, no? So we just have to look up in our National Electrical Code. So saan siyang section, so saan na siya malocate, then look for the applicable demand factor. Then here, so we have, so it's about range again. No? So same with this one. So we have to look at 220.55. So in a 50 unit condominium, each unit has 14 kilowatt range. Okay, then yes, 228, 120 single phase. Then what is the demand on a 3-phase service for this range? Okay, so 50 units. So therefore, yep, so 120. Okay, so we just have to divide by square root 3 later. Okay, so 50, then 14 kilowatts. So if we are to look at the coin on the table, so you see here that we exceeded this table requirement. So therefore, we cannot use column C because according to column C, we can look up for these values no only if we have a rating of not less, more than 12 kilowatt. But here, so we have 14 kilowatt. Okay, so therefore we have to base our calculation now using these notes. Okay, so again, so according to note 1, so we have over 12 kilowatt through 27 kilowatt range of the same rating. Okay, so according to the problem, the same yung ratings, 14 kilowatt tanan with ano, 50 kabo for all the units. Okay, then to apply this note now, so for ranges individually rated more than 12 kilowatt, but not more than 27, so sulod ang 14, the maximum demand in column C shall be increased by 5% for each additional kilowatt rating of major fraction thereof. Okay, so major fraction thereof, man na siyang kasabot na if ever you have 0.5 or more, so you increase to nearest ones, then 0.5 decrease to nearest ones. Okay, range exceeds by 12. Okay, so 14 exceeds 12 by 2 kilowatt. Diba? Okay, so since this each additional kilowatts, therefore, we need to increase our value by 10%. So again, we have 14 kilowatt, 50 kilowatt, and 14 kilowatt. But in our column C, for us to be able to apply that, so we need to have 12 kilowatt lang. So we have to look at di naman ang iyahang excess sa 12 kilowatt. So 12, so we have here 2 kilowatt. Okay, then this 2 kilowatt per kilowatt says that, ako na lang modify, no? So how many percent should I add, no, for me to obtain the actual, the correct demand? Okay, so considering it is 14, so we can, according to note note 1, so it says that I need to have 5% more per additional kilowatt. Okay, so therefore I need to add 10%. Okay, so whatever result nga ako makuha from column C. Okay, so we refer now to column C because this is our base, that is 12 kilowatt. Then 12C, column C is for 12 kilowatt, and not more than 12 kilowatt. So it's up here. Okay, but according to the number, so there are 50. So if we are to calculate the total demand for that feeder, so we have to look at this number. So this is for 41 to 50, so it belongs here. Okay, so this is for column A, for column B, and this is for column C. Okay, so we have to apply this. So for column C, so if there are 50, 41 to 50, so we use this 25 kilowatt plus 3/4 of the range. Okay, so 25 plus 3/4 not over 12 kilowatts. So wait now. Okay, so there are 50. So we multiply it by 50. Okay, that's why nanishay ko ano, we still have to multiply it by 50 because it's not always 50. It could be 41, 42, 43 until mabot 50. Okay, so that's why you have to be specific here. So, upilagi ka book ranges ang nga feeder. Okay, so 25 plus 34. Okay, so correct. Okay, so pila man siya. So 0.75 times 50, 36 plus 25. Okay, so I have here 61 kilowatt. Okay, so imagine if we just use this as it is, so ano siya, 50 times 14, so we'll need 700 kilowatt. So in this case, if we apply demand factor, considering that it's located in different units, no, so probably they will not be used simultaneously. So we can apply certain demand factor. Then according to the code, so we can use this demand load 61 kilowatt. But this is just for this is just for 12 kilowatt. So we still have to apply because the actual rating is 14, so we need to apply this 10% additional load. Okay, so we multiply this by 1.1 so that we have our load good for that 14 kilowatt. Okay, so I have here 67.1 kilowatt. 67. Okay, so what are the choices? Oh, so 67.1. So wala sa choices, no? Actually, I thought nga current ang
Napay
gipangita.
kuan sir, dahil sayop sir.
So, asa man ani?
Kana sa 3/4 times 50 sir. 62 kape ng answer sir.
3 divided by 4 times 50. Oh yeah, so 37.5 there, no? Plus 25. So 62.5. So 62.5 kilowatt. Okay, then 1.1. So I have here 68.75. So it's already in the option. Okay, so thank you for that, no? So what ako kabantay? 68.75 kilowatt. So the answer is letter A. Okay, then suppose you are not looking for the what do you call that, the rating, but you're looking for the load current. So what would be the load current for this feeder? So how do you calculate that? So we have to recall that this is this is three-phase circuit. So we have to use square root of 3. So be careful of that. Okay, so let's just calculate lang para we have an example. So we know that power, and in the code, so we always assume that uh, we always interchange kilowatt and kilovolts ampere. So we always assume the same na sila. So power is equal to square root of 3 VI. Okay, so these are line-to-line parameters. So if we're looking for the line current, so we have to divide 68.75. Okay, so kung lang siya himuon nga 1,000 square root of 3. Then what is the line-to-line voltage for this system? So we have 208 on 20. So probably this is Y connected nga circuit because 208 and 120. So probably we have this kind of connection. Okay, so this is 208 and this is the 120. Okay, so if you want to connect from this phase to this phase, we use this 120. So if you have load no with this line to line voltage, yeah, so we use this 208. So therefore we use 208 here. So 68,750 divided by square root of 3 times, oh, times 208. Okay, so I have here 191 ampere. Okay, so this will be my load current, and this will be my basis now for the calculation of the size of this conductor, okay, or the protection for this feeder. Okay, then, so do we still have, okay, so wala na, no? So, this for total na calculation. Okay, so far, sa questions niya. September ba ang akong ipang-discuss karon?
Sabtan ra man sir. Kanang sir
Saan na ka, sir?
pwede nimo ibalik tong katong 8 gani ang answer sir. Na wala mo ko dito sir.
8. Let me just check now. Yeah, for this one.
Oh, kana sir.
Okay. So yeah, so there are two loads here. So one is counter-mounted cooking, and the other one is oven. Then there is a provision here. So in this note that if ever you have that kind of load, no, so only one cooking and one oven, so you can actually assume that they are a single load. So instead of having two loads, because if you are to calculate that now using these demand factors, so we see here. So let's say that since they both belong no, in column B, so 4 and 6, so that belongs to column B. So we have 2 that belongs to column B, so we multiply them by 65%. Okay, so let's say that individually we multiply them by 65%. So 10 and 4, so 0.65. So pila mo to siya? So 10, 4 times 0.65 and 6 times 0.65. So in total, so that would result to 6.5. Hold on, I sulat na. So there's actually another method, no? If you don't want to look at these notes here, but you have to try everything. So muna siya nga makalibo kung asa nila ang correct answer, because there are what do you call that, ratings that may belong to column A but also may belong to column B, no? So it depends. And so muna siya nga if you apply so the different possible nga combinations, so you will end up of selecting whichever is the greatest nga demand. Okay, so in this case, let's say that let's consider that we have we have 140. So since we have 4 kilowatt and one safety ko, no? So there are just one for each. So therefore 6 instead of 65, so 80% we apply. Okay, so if we are to look at these tables, again, they belong to column B, and since they're just one, so we multiply it by 80%. Okay, so I multiply this by 80% for the demand factor, 80% for the demand factor. So I have here 4 times 8. So I have here 3.2. So 4 times 6 times 0.8. And I have here 4.8. Okay. Okay, so in total, I have a value of 8 kilowatt. Okay, so mo ni siya ang result if we are to apply no kani siya nga column B. Okay, but again, this is not the only possible nga, way of doing this. So we can also refer to note 4. So let's say that we consider that instead of since they are again located in the same room, so we can assume that we are connecting, calculating for the demand of this feeder. Okay, so we calculate the feeder instead of this individual conductors. So since in this feeder, so there are these two loads, so 4 and 6. So in total, we can say that that is equal to 10 kilowatts. So a feeder supplying only one load with 10 kilowatt. So the same way, so we apply So now, since 10 naman siya, so belong na siya to column C. So see here, so it's from 8 and 3/4 to 12 kilowatt. Okay, so mana siya mga values dire. So we apply demand factor. So for 1, so we just use this 8 kilowatt. And again, all that belongs to column C, no? Automatically, ang ilang unit is in terms of kilowatt na. So here for A and B, so these are just factors. Okay, so therefore, since there is just one, this is just one, no? 10 kilowatt, so we use 8. Okay, so it just so happened that for both cases, we have 8 kilowatt. Okay, so the same lang ilang result. But there are some instances, no, in which if you solve through using this method, so you will get, let's say, 7.8. Then let's say you get 8.2. Okay, so you select whichever is the greatest or the greater of the two. Okay, so since pareha naman sila, so either way, so the correct ang answer, solution. Okay, so that's why para dili nakamosolve aning tanan, no? So you have to check pag yun if should I apply column B or column C. So you have to at least familiarize these nodes, no? Kung asa nila ang ma-apply. Okay, so in most cases, good. Kanila gud ang ma-apply kani siyang 1, 2, 3. Then very rare lang ni siyang 4 and 5. Okay, so you have to read through these requirements here. Yep, so natuwa ba na ko yung mga pangutana?
Yes, sir.
Okay, so any other questions?
Pero wala na, sir.
Okay, so next time we'll answer this one. So I'll try to find these mga conductor sizes and current requirements. So this is actually my midterm exam for I think 2018, yeah, 2018. So let's try to apply nila, no, since let's just end at 7 p.m. So let's try to apply these other nodes, no. So for example, kani siyang node 2. So sama natin siya pag-apply. Okay, over 3/4 kilowatt through 27 ranges of unequal rating. Okay, so meaning probably wala na siya dire, so probably it belongs to column C na because it's over 3/4. Okay, then they have an equal rating, but but none exceeds 27 kilowatts. So that is always the limiting rating, so 27 kilowatt. Okay, then an average value of rating shall be calculated by adding together the ratings of all ranges to obtain the total connected load. Okay, using 12 kilowatt. Okay, any range, okay, so dividing the total. Okay, so we apply column C. So let's have that example. So it says here that we have 3/4, 8 and 3/4 to 27. Okay, so let's say we have 12, we have 14, uh, 12, 14, and 16 kilowatts. So see, we have three different ratings. Okay, then none of these exceed 27 kilowatts. So therefore, we can apply node 2. Then to calculate the total kilowatt for this, according to node 2, is we have to take the average of these three. Okay, so since 14 is the mode mean, so that is also the average. So we have here, so we consider that the average here is 14, and we consider now that there are three 14 kilowatt. Okay, so after converting this one, so we see that we can now apply node 1. Okay, so node 1, according to node 1, if your rating exceeds, because this is for same rating, so node 2 is there just to have these different ratings have the same rating. Okay, so 14 kilowatts, so that exceeds again 2 kilowatt based on the 12 kilowatt na base. Okay, then this one, so I multiply this by 5% per kilowatt. So I should increase my demand by 10%. So whatever is calculated from table 20.55. Okay, so there are three. So I have to look at this value. So 3, then it exceeds 12. So therefore, I use 14. Okay, so 14 kilowatt. Ano siya ang based on table. And again, I have to increase this by 10% because it exceeds by 2 from the 12 kilowatt na base. Okay, so 1.1. So that is my 14 times 1.1. So this is my demand for these three loads. So 15.4. Okay, so that is the answer. See, the demand is actually very close to this given rating. So, mahulog nga almost 30% or 33% lang ang ato ang demand factor for this. Okay, so that's how you apply node 2. Then, how about for node 3? Okay, so over 1 and 3/4 through 8 and 3/4. Okay, so in lieu of the method provided in column C, it shall be permissible to add the nameplate ratings of all um, household cooking appliances rated more than 1 and 3/4 but not more than 8 and 3/4, and multiply the sum by the demand factor specified in A or B for the given appliance. Okay, so where the rating of cooking appliance falls under both A and column B, so the demand factor for each column shall be applied to the appliances for that column, and the results add together. So may ito may example. So let me just think of an example now. Okay, so 8 and 3/4. Okay, so let's say that we have 2 kilowatt, 3 kilowatt, and 2 kilowatt. So we have 2 kilowatt, 1 3 kilowatt. Okay, so we have this number of loads. So therefore, if we are to obtain the total, so first, according to node 3, so you have to add up the ratings. So this gives us 4, 7. 7 kilowatt. So since it did not exceed the range from 1 and 3/4 to 8 and 3/4, so therefore we can apply either column B or column A, so whichever it falls to. So since sa man siya belong, so 7 falls at column B, so therefore we use this rating here. Okay, so 7 times 1, so there's just 1, so sinatama silang i-add. So usa na lang kabuok, so we use 80%. Okay, so 80% times 7, so that would be your demand for these loads. So 2 times um, our 7 times 0.8. So I have here 5.6. Okay, so this is my demand for these three ranges. Okay, so I think wala na. Then for the same lang, no? If it falls to column B, so use this multiplier here. Okay, so 80 lang gihapon in this case. So let's say we only have, so lisod kayo na maghimo example. So nga that falls to what do you call it, column A. But anyway, so you get the idea, no? So you just add, there's a total. So this is different from column node 2, no? Because in node 2, you have to take the average, while this one, just take the, what do you call it? Just take the sum, then you consider them as a single load. Okay, then since gagmay naman siya nga rating, so it usually falls to column A and column B. So apply the correct nga demand factor. Okay, then for most of the mga problems sa what do you call that? Board exam SAT is usually similar to this one. So kani siya, mga 50 unit condominium, then therefore you have to apply this certain nga mga demand factor aside from this note 1. And in a board exam, so we do not have this reference, so therefore you have to memorize all of these kani siyang mga demand factors and kani siya nga mga demand for each of these requirements. Actually, once ma-familiarize na nimo siya, so dali na siya i-memorize. Yep, so it's already 7, no? So that's it for today, no? And we'll have, so either we have this one, I think we cannot do this one yet now. So we still have to have an example for the motor loads. Okay, so wala pa ta ka-cover the ring apart. So wala pa ta sa other motor loads, and also wala pa tayo heating and cooling ang example. So we already have this one. General lighting, fixed appliances, clothes dryer, ranges. Okay, so for the next meeting, so we have motor load calculations. Okay, so article 430. Okay, so I hope you learned something today, no? And if you have any questions, so that's it, and you may now leave.
Thank you, sir. Thank you, sir.
Thank you,
Yes, sir.
sir.
Yes, sir.
Na-post na ba na, sir?
Oh?
Na